Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Today we are going to discuss a new chapter in 12th class, that is 15th and 16th group elements. So 15th and 16th group elements are very important. It is just based on 15th group and 16th group elements. So what are these 15th group and 16th group elements I would like to discuss now. So this is coming under inorganic chemistry. So far we have done already physical chemistry, all the 5 chapters, that is solid state, surface chemistry, chemical kinetics, electrochemistry, and dilute solution. Now we are going to do inorganic chemistry part, that is for 12th class, group 15th and 16th, 17th, group 15th and 16th in this chapter. So first we'll do group 15 elements, then we'll do group 16 elements. So what are these group 15 and group 16 elements we'll discuss right now. It's very easy topic, and only this inorganic chemistry part is only memorizing with a little bit of logic. So that points we are going to discuss now. So what are p block elements? Now we are going to discuss what are p block elements. Since already you know in 11th class also we have done about p block elements. So what are p block elements? Right now we are discussing the elements in which the differentiating electron enters p subshell of the outermost shell are called as p block elements. The elements in which the differentiating electron, what is differentiating electron? Differentiating electron means valence electron. So it is nothing but what? Valence electron. So the elements in which the valence electron enters into p subshell of the outermost shell are called as p block elements. So what are p block elements? Elements of group 13 to 18 belongs to p block elements. So from group 13 to group 18, 13 and 14 we'll study in 11th class. Already it is done. So 13 group and 14 group elements, we'll do it in 11th class, and 15, 16, 17, 18, we'll do it in 12th class, now the present class. So in this class, we are going to discuss about p block elements. So what are p block elements? If the differentiating electron enters into p subshell of the outermost shell, they are called as p block elements. So example, p block elements nitrogen, if we take into consideration nitrogen. So nitrogen, what is atomic number? 7. So configuration is 1s2, 2s2, 2p3. So the last valence electron enters into p subshell. So it is called as p block element. So what are p block elements? I hope you understood. So elements of groups 13 to 18, 13 group elements to 18 group elements are considered as p block elements. So in this class, we are going to discuss about 15th group elements. So that is nitrogen family. So the group 15 includes, what are the elements in group 15? It includes nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. This is coming under nitrogen group, where the differentiating electron, that is the valence electron enters into the p subshell of the outermost shell. Nitrogen, phosphorus are non-metals. So what are the existence now? Nitrogen and phosphorus are non-metals. They belong to non-metals, and they have all the properties of non-metals. Arsenic, antimony are metalloids. They are nothing but what? Metalloids. And bismuth is a metal. So in this group, only one metal and two non-metals and two metalloids. So what are metalloids? Means which have properties of both metal as well as non-metal. That's why they are called as metalloids. Usually these metalloids are used as semiconductors. Arsenic and antimony used as semiconductors. So metalloids are used as semiconductors. So the elements of group 15 are also known as nicogens. P silent here. They are called as nicogens. Why? Because they are hydrides. That is the hydride of nitrogen, arsenic, antimony, bismuth, and phosphorus are poisonous in nature, except nitrogen. All other hydrides of this group are poisonous in nature. As they are poisonous in nature, they are also called as nicogens. So why these group 15 elements are called as nicogens? Because they are hydrides. What is the hydrides of the type formula? MH3, because hydrogen valence is 1, and this elements of group 50, their valence is 3, so they form hydrides of type MH3. And these hydrides like ammonia, phosphine, you know, it's used as poisonous gas. That's why it is used in wars. So phosphine, etc. All these metals hydrides are poisonous in nature. That's why they are also called as nicogens. So the elements of 15 group are also known as nicogens due to their poison. The hydrides are poisonous in nature. I hope it is clear. So this is the introduction of 15th group elements. So what are the 15th group elements we have? We have nitrogen, phosphorus, arsenic, antimony, and bismuth. The group 15 element is also known as nitrogen group. So out of these 15th group elements, nitrogen and phosphorus are non-metals, arsenic, antimony, and bismuth. Arsenic and antimony are metalloids, and bismuth is a metal. Next, occurrence. So in every chapter we'll study about like how we'll study. We have studied this in first 11th class. The same thing here also will follow. That will start with general physical properties, then general chemical properties, then preparation of compounds, then uses of compounds, then finally questions. So same thing here also we are repeating now. So how do these elements occur in nature? Nitrogen gas present in air is 78% by volume. So already we know air contains 78% of nitrogen in air. It is by volume. So that's why the most abundant gas in atmosphere is nitrogen gas. The most abundant element in atmosphere is nitrogen because it occupies 78% of air by volume. Nitrogen compounds existing in nature are it is nothing but Chile saltpeter, that is also called as sodium nitrate, and Indian saltpeter, that is potassium nitrate. So how does nitrogen exist in nature? Are nothing but in the form of minerals. They form like Chile saltpeter and Indian saltpeter. The formula is NaNO3 and KNO3. These formulas also they'll ask. These are the formulas of ores or minerals of nitrogen. So they'll ask in the examination the formula of the ore or minerals. So in Indian, it is Indian saltpeter, it is potassium nitrate, sodium nitrate, and potassium nitrate. From minerals containing phosphorus. So now how do phosphorus exist in nature? It is nothing but fluorapatite. The formula is Ca3 calcium phosphate along with calcium fluoride. That is Ca3PO4 taken twice, CaF2. Fluorapatite, Ca3PO4 calcium phosphate along with calcium chloride, and phosphate rock only calcium phosphate. So these are the minerals of containing phosphorus. So nitrogen exists in nature and phosphorus exists in nature like this. I hope it is clear. These formulas of the minerals are important. Phosphorus is an essential element for plants and animals because it contains in bones. So that's why phosphorus is an essential element for plants and animals. Antimony and bismuth are found mainly in sulfide minerals. Antimony sulfide, that is, and bismuth sulfide. So these are the occurrence of elements, arsenic, antimony, and so arsenic is an essential element for plants and animals. Antimony and bismuth are found mainly in sulfide minerals. So I hope it is clear. Next. General properties of group 15 elements. So first we'll discuss general physical properties and then we'll discuss the trends and general chemical properties. So these general properties only very important in all the groups because from these general properties definitely they'll ask you the trends of different substances like electronegativity, electron affinity, atomization or atomicity, atomic radius, hydrides, basic nature, acidic nature, etc. etc. They'll ask so many questions. How they'll ask questions in the examination also we are going to discuss today. So now let us see general properties of group 15 elements. General properties of group 15 elements. Electronic configuration. As I told you, all the general properties is this only. Electronic configuration, atomic radii, ionization enthalpy, electronegativity, oxidation states, covalency. So electronic configuration, we know how to write. And atomic radius, what is atomic radii? The distance between the center of nucleus to the outermost orbit. The distance between the center of the nucleus to the outermost orbit of an element is called its atomic radii. Ionization enthalpy, the amount of energy required to remove the valence electron from a neutral gaseous atom. The amount of energy required to remove the electron from a neutral gaseous atom is called ionization enthalpy or ionization potential. Electronegativity, the tendency of an atom that the tendency of an atom to attract the shared pair of electron towards itself is called as electronegativity, or even the amount of energy released is electron affinity. So the tendency of an atom to attract the shared pair of electron towards itself is called electronegativity. Oxidation states. What are the different oxidation states exhibited by these elements that we are going to study? And also covalency. With how many other atoms it will form the compounds. So all these points are coming under general physical properties. Not only this, we have boiling points also as well as melting points. Let us see now electron configuration. The outermost electron configuration of group 15 elements, only this group, that is nitrogen, arsenic, phosphorus, antimony, bismuth. All these elements have the common configuration, that is NS2 NP3. So this outermost configuration is important. It is nothing but NH2NP3. If you know the outermost configuration, without remembering atomic number, you can write the outermost configuration. So as I told you, nitrogen atomic number is 7. So it has helium 2s2 2p3, phosphorus 15 3s2 3p3, arsenic 33 4s2 4p3, 5s2 5p3 for antimony, and bismuth 6s2 6p3. So these are the electronic outermost configurations, general outermost electronic configurations of group 15 elements. I hope it is clear. So they have 5 electrons in the valence shell. That's why they are placed in group 15. As they have 5 electrons in the valence shell, that's why they are placed as group 15 elements. These are also called as 50A group elements. These are also called as 50A group elements because they have 5 electrons in the valence shell. As they have 5 electrons in the valence shell, they are also considered as 50A group elements, 60A group elements, like that it goes on. So NS2, NP3. So these are the trends. I hope it is clear. Next property, atomic radii. As we go down the group, the atomic radii and ionic radii in group 15 decreases. As we know, atomic radii decreases because as a number of as we go down the group, the atomic radii and ionic radii in group 15 decreases. From arsenic to bismuth, there is only a small increase in radii due to ineffective shielding of completely filled D and F subshells. The order of atomic radius is nitrogen less than phosphorus. Atomic radii and ionic radii increases. It should not be decreases. That's what I'm saying here. So it should be increases. Any group, if you take down the group, the atomic radius and ionic radii increases because of addition of extra shell. As the atomic number increases, automatically the atomic radii increases. So from arsenic to bismuth, there is only a small, and this change is very important. From arsenic to bismuth, there is only a small increase in radii because due to ineffective shielding of completely filled D and F orbitals, F subshell. So that's why due to poor shielding effect, there is no much difference between the atomic radius of arsenic to bismuth. Poor shielding effect. What is shielding effect? The inner electrons cannot shield properly the outer electrons, due to which what happens? The outer electron will come closer to the nucleus, and this is called as shielding effect or screening effect. Due to poor shielding effect of D and F orbitals in case of arsenic to bismuth. So these have very, very little differences between the atomic radius. However, the atomic radius order is nitrogen less than phosphorus, less than arsenic, less than antimony, less than bismuth, and you will not find much difference like in other groups in between these. The atomic radiuses of arsenic, antimony, and bismuth are very close. They are very close to each other because their value is very similar as due to poor shielding effect. This will not observe in other groups such as first group and second group elements because they do not have poor shielding effect. Whereas 13 group, 14 group also will not have that much, but whereas from 15th group onwards, since the D and F orbitals are involved, and due to poor shielding effect, the atomic radius of arsenic, antimony, and bismuth are very close to each other. That's why they do not have that much difference. But however, arsenic is less than antimony is less than bismuth. The atomic radius of arsenic is less than antimony is less than bismuth. So this is the trend. These trends only they'll ask in the examination. So this is a general trend of atomic radii or ionic radii for 15th group elements. That is, the trend is increasing order: nitrogen less than phosphorus, less than arsenic, less than antimony, less than bismuth. I hope it is clear. So this is the trend of atomic radius. Let us discuss now next property, ionization enthalpy. The amount of energy required to remove the valence electron of a neutral gaseous atom is called ionization enthalpy or ionization potential. Since the atomic size increases down the group, as we have seen 7, 15, 33, and so on in the atomic numbers of 15 group elements. Since the atomic size increases down the group, the ionization enthalpy decreases down the group. It's very easy to remove the valence electron down the group because the nucleus is far from the outermost electron. Since the nucleus is far from the outermost electron, easily we can remove the electron. That's why in any group, not only in this group, the ionization enthalpy decreases down the group. The ionization enthalpy decreases down the group. The ionization enthalpy of group 15 elements is higher than that of group 14 due to half-filled p subshells, as they have, since half-filled and completely filled are more stable than usual. So we can say since 15 group elements have half-filled, because this is completely filled and this is half-filled electrons. So Naturally, the atomic radius, the ionization enthalpy is greater than 14 group elements due to half-filled p subshells. What are the 14 group elements? We have ns2 np2 configuration. So this is not half-filled; it is only partially filled. Whereas this is half-filled and this is completely filled. So that's why automatically the ionization enthalpy of group 15 elements is higher than that of group 14 due to half-filled p subshells. And that trend, the ionization enthalpy trend is nitrogen. As we go down the group, the ionization enthalpy decreases. So highest will be for nitrogen because the outermost electron is very close to nucleus. Next is phosphorus. Next is arsenic, antimony, and bismuth. So this is the trend of ionization enthalpy for group 15 elements. Nitrogen greater than phosphorus, greater than arsenic, greater than antimony, greater than bismuth. So this is second property that is called ionization enthalpy. Let us see now electronegativity. As we know, the tendency of an atom to attract the shared pair of electrons towards itself is called electronegativity. Usually, electronegativity is more for non-metals when compared to metals and metalloids. So, electronegativity automatically decreases down the group since nitrogen and phosphorus are non-metals and arsenic and antimony are metalloids with the increase in size. So, electronegativity decreases down the group with increase in size, and however, nitrogen is highly electronegative because of its non-metallic nature. Next is phosphorus. Next, arsenic and antimony are metalloids, and bismuth is metal. So metals have less electronegativity than non-metals usually. So non-metals, since nitrogen and phosphorus are non-metals, they have high electronegativity than the remaining elements in this group. So this is a trend of electronegativity for this group elements. I hope it is clear. Next. Oxidation states, very important. This any group, the oxidation states are very important because that is only deciding many properties, because they'll form with their different oxidation states, they'll form variety of compounds. The common oxidation state of group 15 elements are -3, +3, and +5. -3, +3, and +5. So for example, nitrogen, you can see here, nitrogen in the case of ammonia, it is -3, whereas nitrogen in the case of N2O5, it is +5, because nitrogen is less electronegative than oxygen. So nitrogen will take positive oxygen state. So the common oxygen states of 15 group elements are -3, +3, and +5. So -3, bismuth will have only +3. Bismuth will have only +3 oxygen state only. It will not have -3 because it is a metal. It cannot be negative. Nitrogen, phosphorus can form -3, +3, and +5. So like now phosphorus, if you take phosphine, it is -3, and PCl3. Chlorine is more electronegative than phosphorus, so it is +3, and PCl5, it is +5. So that's what I'm telling. So the common oxidation state of group 15 elements are -3, +3, and +5. Arsenic and antimony will form +3 and +5. Bismuth will form only +3. Nitrogen exhibits from -3 to +5 due to its small size and high electronegativity. So nitrogen can exhibit all the oxidation states, that is -3 to +5, due to its small size and high electronegativity. As it is forming many many oxidation states, it will leads to the form, as it is exhibiting so many oxidation states, it leads to the formation of many compounds. So nitrogen can have the tendency to form many compounds. So nitrogen has a tendency to form many compounds as it exhibits from -3 to +5 due to inert pair effect. Stability of +3 increases down the group, and stability of +5 decreases down the group. Very important point this is. What is inert pair effect? What is inert pair effect? The reluctance of, I'm writing inert pair effect in a clear pattern. Yes, please note down in your classwork what is inert pair effect. Usually this will be shown by p block elements only. So the inert pair effect is nothing but the reluctance of s orbitals in bonding. Reluctance means non-involvement. The reluctance of s electrons in bonding is called as in bonding. Means they will not involve in bonding is called inert pair effect. Is called inert pair effect. So what is this reluctance of s electrons? Because since as we go down the group, the inert pair effect increases. Due to inert pair effect, stability of plus 3 increases down the group and stability of plus 5 decreases down the group. So plus 5 state it is less when compared to plus 3. Means for example here, arsenic chloride AsCl3 is more stable than arsenic pentachloride, that is AsCl5. So this based on this, definitely the last question, this point is most important. Due to inert pair effect, stability of plus 3 increases down the group and stability of plus 5 decreases down the group. So bismuth chloride does not form. Bismuth will form BiCl3. So the oxygen states from nitrogen from plus 1 to plus 4 will disproportionate in acidic solution. Disproportionation reaction means same element is undergoing oxidation as well as reduction. So here you can see here nitrous acid on disproportionation gives nitric acid, nitric oxide along with water. If you see the oxygen state of nitrogen here, it is 1 plus x minus 4. That is x. Nitrogen is plus 3 and here it is plus 2 and here it is hydrogen 1 and a minus 4. So it is plus 3. So it is changing from, so this is plus 5. Plus 3 changes to plus 5 and as well as plus 2. So decrease in oxidation number as well as increase in oxidation number. Hence it is called disproportionation. So what is disproportionation? Already you understood, I believe. The same element undergoing oxidation and as well as reduction. So here if you see the nitrogen element, the oxygen state of nitrogen is plus 3 in the left hand side and is going on the right hand side, it is plus 5 as well as plus 2. This is increase in oxidation number as well as decrease in oxidation number. Decrease in oxidation number is called reduction and increase in oxidation number is called oxidation. So same nitrogen is undergoing oxidation as well as reduction. So due to this, what happens? As nitrogen is undergoing oxidation and reduction, it is called as disproportionation reaction. So the oxygen states from of nitrogen from plus 1 to plus 4 will disproportionate in acidic solution. Disproportionate in acidic solution, that is nitrous acid changes to nitric acid along with nitrogen oxide along with water. I hope it is clear. So this is nothing but the oxidation states of nitrogen only. Now we will discuss more about oxidation states of other elements in this chapter. Next, covalency. Maximum covalency of nitrogen is 4. Nitrogen can form maximum 4. The elements like phosphorus, arsenic can show covalency up to 6 due to the presence of vacant d orbitals. So phosphorus can form up to 6. Arsenic can form up to 6. Whereas nitrogen can form only 4. For example, nitrogen covalence is 4. That is NH4 plus. So the covalency of nitrogen is one nitrogen atoms combined with 4 different atoms of hydrogen. Whereas phosphorus can form 6, arsenic can form 6, covalency up to 6 due to the presence of vacant d orbitals. Whereas antimony bismuth will form covalency of up to maximum 5. I hope it is clear. So this is called covalency. Now, anomalous properties of nitrogen. So in this group, nitrogen is different from all other elements, especially in certain characteristics. So that characteristics we are going to discuss now. So that is called anomalous properties of nitrogen. So what are the anomalous properties of nitrogen? Formation of p-pi multiple bonds due to small atomic size. So it will form pi bond. Why? Because in nitrogen, already we know nitrogen combines with other nitrogen in the form of triple bond because they share 3 electrons. Due to the formation of triple bond between two nitrogens, they have what sort of bonds? One sigma bond and 2 pi bonds, because triple bond is there. That 2 pi bonds are nothing but p pi multiple bonds. Due to the formation of p pi multiple bonds due to small atomic size of nitrogen, they can form p pi multiple bonds, due to which it is different from other atoms in this group, because other elements cannot form all these things. Chemically inert. Nitrogen is chemically inert due to the high N triple bond N bond energy. So if nitrogen has to combine with any other element like hydrogen, etc., it should break up this nitrogen bond. And this bond energy is high because it is combined to form with triple covalent bond. As they are having triple covalent bond, the bond energy is higher. So that's why usually the nitrogen is chemically inert because of high bond dissociation enthalpy of nitrogen. As nitrogen has high bond dissociation enthalpy, it is chemically inert. And if you want to take nitrogen into consideration, we have to give high energy so that first the bonds of nitrogen will break up and form the new compound with other elements. So that's why nitrogen is generally chemically inert. That's why atmospheric nitrogen is also inert. Nitrogen single bond strength is less than pp single bond strength due to inter-electronic repulsion. So nitrogen single bond strength is less than P single bond strength due to inter-electronic repulsion. Maximum covalence of nitrogen is 4 only due to the absence of d orbitals and highest electronegativity in the group. These are the anomalous properties. How nitrogen is different from other elements in this group. These are the factors. Not only these, some more factors are also there that we are going to discuss now. Now, so these are the anomalous properties of nitrogen. Now, these now we have completed already general physical properties. General physical properties. Now we are going to discuss general chemical properties. So hydrates of group 14. Since hydrates of group 15, group 15, hydrates of group 15. Since hydrates of group 15 are poisonous in nature, that's why they are also called as nicogens. And what are the common formula of hydrates? These elements form hydrates with general formula MH3 only. All hydrates are pyramidal in shape due to sp3 hybridization. Why they are pyramidal? Even though they are undergoing sp3 hybridization due to the presence of lone pair of electrons. Lone pair of electrons. How it is possible? You can see here. Ammonia, nitrogen has how many valence electrons? 5 valence electrons. So with 3 electrons, they combine with 3 hydrogens. So three hydrogens, one hydrogen, two hydrogen, three hydrogen, and this becomes lone pair. Not only for this, every element will have lone pair in this group because they have 5 valence electrons in their valence shell. So due to this, what happens? Due to this, what happens? They are having pyramidal shape. Even though they undergo sp3 hybridization, they are having pyramidal shape because the bond length decreases due to the presence of bond angle decreases due to the presence of one lone pair of electrons. I hope it is clear. So all hydrates are pyramidal in shape due to sp3 hybridization. Stability, Lewis basic nature, bond angle, MH bond energy decreases from ammonia to bismuth hydride. So basic nature decreases from ammonia to bismuth hydride. Stability also decreases from ammonia to bismuth hydride. So bond angle, the bond angles from ammonia to bismuth hydride also decreases, and MH bond energy, that is single bond energy, also decreases from ammonia to bismuth hydride. So these trends they'll ask in the examination. So the the decreasing order of the basic nature of hydrides of 15 group elements. They'll ask a question like this. Write the decreasing nature of this decreasing basic nature of hydrides of 15 group elements. Then we have to write the order like this: ammonia greater than phosphine greater than arsenic hydride greater than antimony hydride greater than bismuth hydride. So this is the basic nature. As we go down the group, the basic nature decreases. Stability, Lewis basic nature only. And bond angle, MH bond energy decreases from ammonia to bismuth hydride. So these orders are very, very important. So this point is very, very important. Please note it down. So stability, the stability of hydrates decreases down the group. The basic nature of hydrates decreases down the group. Bond angle also decreases down the group. MH bond energy also decreases down the group, and so on. Next, reducing nature, acidic nature, MH bonds increase from ammonia to bismuth hydride. Reducing bismuth, already since bismuth is metal, so its reducing nature is high because metals are good reducing agents. Acidic nature also increase from ammonia to bismuth hydride. This is slightly acidic, and this is again basic. So reducing nature, acidic nature, MH bonds increases from ammonia to bismuth hydride. So all these points are important. So these are the nature of hydrates of 15 group elements. And moreover, due to absence of intermolecular hydrogen bonding, phosphine has a low boiling point than ammonia. So the boiling point order, phosphine has low boiling point than ammonia due to the absence of intermolecular hydrogen bonding. Due to the absence of intermolecular hydrogen bonding, phosphine has lower boiling point than ammonia because in ammonia it has intermolecular hydrogen bonding, due to which what happens, the boiling point of ammonia is greater than phosphine, and bond angles decreased and reach to 90 degrees due to pure orbitals involvement. So this is the nature of bond angles. So as we go down the group, the bond angles decreases, and due to the presence of intermolecular hydrogen bonding, phosphine has lowest boiling point. Out of this, the boiling point order of hydrates is pH 3 less than ammonia less than arsenic hydrate because it is a metalloid hydrate, less than antimony hydrate, less than bismuth hydrate. So these the trends of hydrates, boiling points of hydrates of 15th group elements, boiling points of phosphine less than ammonia. This trend is important. The trend which is going abnormal property, that is important because that type of questions only they'll ask in the examination. So phosphine is less than ammonia, less than arsenic hydrate, less than antimony hydrate, less than bismuth hydrate. Why ammonia is having greater boiling point than phosphine, even though it has small atomic size? Because of intermolecular hydrogen bonding. Nitrogen is having more boiling point than phosphine because of intermolecular hydrogen bonding. I hope it is clear. So these are the trends of boiling points as well as bond lengths as well as bond angles. As we go down the group, the bond angles decrease. You know, bond angle of ammonia is 107.8 degrees. Next bond angle is phosphine is 93.6, arsenic hydrate 91.8, and all undergoes what type of hybridization? They undergoes sp3 hybridization, sp3 hybridization. All hydrates of this undergo sp3 hybridization. This already we have seen in the previous slide. So sp3 hybridization, and their shape is pyramidal in shape. What is the shape of these molecules? Pyramidal shape. So all these molecules have a common shape, that is pyramidal shape, but the bond angle is slightly decreasing from top to bottom. I hope it is clear. So these are the trends only they'll ask in the examination. Next, oxides of group 15 elements, very, very important. These elements forms mainly, since we have done first hydrates, next we have oxides, next we have halides. So second chemical properties have oxides. So these elements mainly form M2O3 and M2O5. That is dinitrogen trioxide, that is N2O3. So they form N2O3, N2O5. Mainly, not only nitrogen, phosphorus P2O3, P2O5. So phosphorus also P2O3, P2O5. Arsenic also AS2O3, AS2O5. Antimony also Sb2O3, Sb2O5. And bismuth will form only, bismuth also will form Bi2O3 and Bi2O5. So nitrogen, from nitrogen to phosphorus, all other atoms not only forms these, other oxides also they'll form. So these elements form mainly M2O3 and M2O5. This is common to all. This is common to all elements. Whereas not only this, they will form different oxides based on the element. So these oxides show acidic property, basic property, or even amphoteric oxides also. So N2O3 and P4O6 are highly acidic in nature. N2O5 is also acidic in nature. N2O5 is also acidic in nature, since I already have seen here. And N2O5, P4O10 also acidic in nature. AS4O6, as their amphoteric means here, metalloid oxides, oxides of metalloids. So AS2O4, AS4, AS2O5, or AS4O10, and AS4O6, that is AS2O3. So they'll form, they are nothing but amphoteric oxides, and bismuth oxide is basic, and bismuth oxide means the oxides of bismuth are basic, that is +3 as well as +5 state, whereas the other oxides, nitrogen and phosphorus, are acidic because they are non-metals, and the oxides of metalloids, that is antimony and bismuth, are amphoteric in nature. So this is the nature of oxides of go 15 elements. Against this, they'll form many other oxides also. The common oxides formed by 15th group elements are M2O3 and M2O5, where M is called 15th group element. So nitrogen can form N2O3 and 2O5. Phosphorus also can form P2O3 and P2O5. Arsenic also can form AS2O3, AS2O5. So as they exist as dimers, we'll write it as AS4O6 and AS4O10. And Sb4O6, Sb4O10. So if you take monomer of this is how much? AS2O3, AS2O3, but they exist as AS2. Here also Sp2O3. They exist as dimers. Dimers means two atom, two molecules combined together. So since they exist as dimers, we'll write a formula like this. And bismuth exists as monomer. So bismuth oxide Bi2O3 and bismuth oxide Bi2O5. These are basic nature because metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature, whereas metallic oxides are basic in nature, and metalloids oxides are amphoteric in nature. By this you can write Non-metal oxides. Non-metal oxides, usually they are acidic in nature. Metallic oxides. Metallic oxides, basic in nature. Whereas metalloid oxides. Metalloid oxides, metalloid oxides, usually they are amphoteric in nature. Amphoteric in nature. So these are the nature of oxides of 15 group elements. Usually they form oxides of type M2O3 and M2O5. In addition to this, nitrogen and phosphorus will form. Nitrogen will form many other oxides such as nitric oxide, NO, N2O, and NO3, nitrogen trioxide, and also N2O, NO2, nitrogen dioxide, N2O5. So NO, N2O, NO2, N2O5. So nitrogen in +4 oxygen state. Here the oxygen state of nitrogen is different. Here also different, and here also different. Whereas here the oxygen state of nitrogen is +2. Here it is +1 only. Whereas here N2O3 2x is equal to, so it is +3, and here it is +4, and here it is +5. So +2, +1, +3, +4, +5. So the oxygen states of nitrogen in +2 and +1. These two are neutral oxides. These two are what? Neutral oxides. Nitrogen in its lower oxygen state are said to be neutral oxides. And these three are acidic oxides. Nitrogen in its higher oxygen state will form acidic oxide. Generally, non-metallic oxides are acidic in nature, but the non-metallic oxides which are in the lower oxygen state, you remember this point, very important, please listen carefully. The non-metallic oxides which are in their lower oxygen state are nothing but neutral oxides. So example, NO +2 state, N2O +1 state of nitrogen. They are neutral in nature. They are neither acidic nor basic. They form neutral oxides. Whereas N2O3, NO2, and N2O5 form acidic oxides. I hope it is clear. Next. Please note down whatever I have written on the slides. Next, halides of group 15 elements. What are the halides of important halides of group 15 elements? So, as I told you, first hydrates, next oxides, next halides. So, let us see the halides of group 15 elements. They have these elements will form halides of type MX3 and MX5. Nitrogen cannot form does beta halide due to the absence of d orbitals. So, what are the halides it will form? For example, nitrogen can form NH3, NF3, and so on. And phosphorus can form PCl3, PCl5. All other elements can form halides of type MS3 and MX5 except nitrogen. So PCl3, for example, arsenic halide ASCl3, ASCl5. I'm giving one example. Next, antimony halides SbCl3, SbCl5. Bismuth halides BiCl3 as well as BiCl5, but tendency is less in this case. So nitrogen cannot form pentahalides due to the absence of d orbitals. That's why they can form only trihalides. Sorry, this is not ammonia. We have to write here. I'll just rub it here. This will form only NCl3. It is not ammonia, it is NCl3. X means halogens. X can be fluorine, chlorine, bromine, and iodine. So I hope it is clear now. So what are the halides of type MX3 and MX5? And nitrogen cannot form MX5 type because of absence of d orbitals. Next, general trends in properties of halides of 215 elements. Except BiF3, bismuth trifluoride, all the remaining trihalides are predominantly covalent. Very, very important. Since bismuth is metal and this is non-metal, so it is ionic in nature. But all other all other trihalides are predominantly covalent in nature. Among halides, pentahalides are more covalent than trihalides. NF3 cannot be hydrolyzed due to the presence absence of vacant d orbitals. NF3 cannot be hydrolyzed. The stability of nitrogen halides are NF3 greater than NCl3 greater than NBr3 greater than Ni3. So these are the general trends in the properties of halides of group 15 elements. Very important is BiF3, even it is metallic and non-metallic nature. So bismuth is metal and fluorine is highly electronegative element. So that's why the bond is ionic in nature. And all of the remaining trihalides, that is PCl3 or AsCl3 or antimony Cl3. So all these are predominantly covalent in nature. Among halides, pentahalides are more covalent than trihalides. So PCl5 is more covalent than PCl3. Similarly, ASCl5 is more covalent than ASCl3. SbCl5 is more covalent than antimony, bismuth, etc. So NF3 cannot be hydrolyzed, cannot be. NF3, that is nitrogen trifluoride, cannot be hydrolyzed due to absence of vacant d orbitals. And stability of nitrogen halides is in the order NF3 less than, sorry, greater than NCl3, greater than NBr3, greater than Na3, which is more stable. NF3 is more stable. I hope it is clear. So these are the trends of halides of 15 group elements. Next, reactivity towards metals. All the elements of group 15 react with metals to form binary compounds with oxygen state of -3. So they'll combine with metals because they are less electronegative, sorry, more electronegative than metals. So that's why they'll form binary compounds with oxygen state of -3. Calcium nitrate, calcium phosphide, sodium arsenic, and zinc actinamide, and magnesium bismuthide. So the oxygen state of bismuth is -2 here, negative oxygen state, negative, negative, and negative oxygen state and negative oxygen state, that is -3. All the oxygen states here it is -3. So even though bismuth is a metal, but it exhibits -3 oxygen state. Bismuth is a metal, but it exhibits -3 oxidation state when it combines more active metals. I hope it is clear. So these points are very, very important. All the elements of group 15 react with metals to form binary compounds with oxidation state of -3. Very, very important. Next, preparation of dinitrogen. Now, since we have completed general properties and general properties of 15 group element, that is both physical as well as chemical properties. So now we'll discuss the preparation of nitrogen, etc. So preparation of and compounds we are going to deal with now. In the laboratory, nitrogen is prepared by reacting ammonium chloride with sodium nitrite. So ammonium chloride combined with sodium nitrate to form nitrogen gas, water, and NaCl. So in the laboratory, nitrogen is prepared by reacting ammonium chloride with sodium nitrite, NaNO2. Small amount of impurities like nitric oxide, um, nitric acid are removed by passing through aqueous sulfuric acid solution containing potassium dichromate. So this point is important. So just preparation of nitrogen. Anyway, they may ask preparations, but usually they will not ask. So small amount of impurities like nitric oxide, HNO3 are removed by passing through aqueous sulfuric acid solution containing potassium dichromate. I hope it is clear. So next is the preparation of dinitrogen. It is also prepared by the thermal decomposition of ammonium dichromate. By the thermal decomposition of ammonium dichromate, we can obtain nitrogen gas in the laboratory. Plus chromium oxide is a byproduct. Very pure nitrogen can be obtained by the thermal decomposition of sodium or barium azide. This reaction is important. So this they'll ask in the examination, complete the following reactions. So sodium azide, barium azide. It forms sodium along with barium along with nitrogen gas. So this is called azide. Azide means three nitrogens, three nitrogens. So it is also prepared by the thermal decomposition of ammonium dichromate. I hope it is clear. Next. Reactions of dinitrogen, how nitrogen combines with other elements. Now, Dinitrogen, that is nitrogen N2, is a colorless, odorless, tasteless, and non-toxic gas. It has two stable isotopes, N14 and N15. N14 is more. Metals like lithium and magnesium have affinity towards nitrogen and forms their respective nitrides. So they'll combine with metals and form magnesium nitride as well as lithium nitride. Whereas sodium, potassium will not combine with nitrogen. Only metals like lithium and magnesium, sodium, calcium, and all means first group metal and second group metals. In that first group metals, only lithium will combine with nitrogen along with magnesium combine with nitrogen. So second group metal. Remaining all metals in the first group and second group does not combine with nitrogen directly, and they do not form nitrides. So metals like lithium and magnesium have affinity towards nitrogen and forms respective nitrides of the formula Mg3N2Li3N. Next, dinitrogen combines hydrogen in the presence of iron as catalyst and molybdenum as promoter to form ammonia. This is also called as Haber's process. So this is Haber's process, and it is an exothermic reaction at high pressure. Haber's process. We can change nitrogen. We can combine nitrogen and hydrogen at high pressure in the presence of iron as catalyst and molybdenum as promoter. So iron as catalyst, Fe as catalyst, and molybdenum as promoter, we can form ammonia. Ammonia is formed. It combines with the dioxygen and forms nitric oxide. Nitric oxide delta H is plus 2000 kilojoules endothermic reaction. And nitric oxide, it is neutral in nature because the oxygen state of nitrogen is only plus 2. So nitric oxide is neutral in nature. Neutral oxide. It is a neutral oxide. Next. In the manufacture of ammonia, calcium cyanide, etc., it is nitrogen is used. Now uses of dinitrogen to provide inert atmosphere in metallurgical processes. To provide inert, because nitrogen is highly inert because it has high bond and dissociation enthalpy. So that's why it is used in metallurgical processes. What are metallurgical processes? The process in which metals have been extracted. Yeah, nothing but metallurgical processes. So in that process, we'll use nitrogen to provide inert atmosphere. And liquid dinitrogen is used as refrigerant in order to preserve biological materials, food items, etc. So these are the main uses of nitrogen. Liquid dinitrogen is used as a refrigerant storage, cold storage, in order to preserve biological materials as well as food items. I hope it is clear. Next. Example one now. In what way it can prove that phosphine is basic in nature? Phosphine is basic in nature in what way can prove? Because phosphine has a lone pair of electrons due to which it is basic in nature, and the basic character decreased on the group. Ammonia is more basic than phosphine, as phosphine has lone pair of electrons. Since already I told you, so phosphorus has 5 valence electrons in the valence shell. So 3 electrons will be like this, and 3 electrons will come with 3 hydrogens, and so due to which what happens, it forms pyramidal shape sp3 hybridization, and it has one lone pair. This is called lone pair of electrons. Lone pair of electrons. As it contains one lone pair of electrons, it is basic in nature. I hope it is clear. Next. Example 2. Phosphine has lower boiling point than ammonia. This is also very important because in ammonia, as ammonia contains intermolecular hydrogen bonding, it has intermolecular hydrogen bonding, whereas in phosphine it does not present. So due to the presence of intermolecular hydrogen bonding, ammonia is having more boiling point than phosphine. Phosphine has lesser boiling point than ammonia because in phosphine no intermolecular hydrogen bonding, whereas in ammonia intermolecular hydrogen bonding is present. So that's why there is intermolecular hydrogen bonding in ammonia, whereas it is not present in phosphine. Hence the boiling point of phosphine is lower than ammonia. I hope it is clear. Next question. So like these simple questions only you'll get in the examination. Bond angle in phosphine plus pH4 plus is higher than in phosphine. Why? Because it undergoes sp3 hybridization and it has no lone pair electrons, as it has no lone pair because pH4 plus means P, hydrogen, 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 as well as hydrogen. So 4 hydrogens and one lone pair is present. So that one electron will combine with positive charge, due to which what happens, it forms. It has no lone pairs. As it has no lone pairs, so automatically the bond angle is more. because in phosphine we have one bond, one lone pair. In phosphine we have one lone pair, due to which what happens, the bond angle is less. So I hope it is clear. This is also undergoing sp3 hybridization. This is also undergoing sp3 hybridization, but the bond angle is slightly lower in phosphine because of one lone pair of electrons, whereas the bond angle in pH4 plus is having 109 degrees as usual, like methane. And shape is also, this is tetrahedral because there is no lone pair of electrons, and the shape, due to the presence of lone pair, its shape is pyramidal in nature. So shape is pyramidal in case of phosphine, and pH4 plus is tetrahedral in nature. So I hope it is clear. So these points please note down, very very important. pH4 has tetrahedral structure with 4 bond pairs of electrons. All the 4 bond pairs of electrons, only one lone pair, and that also with positive charge. This also will go off, due to which what happens, as it has no lone pairs, it has tetrahedral structure with the bond angle 109 degrees, and it has pyramidal structure with bond angle exactly around 98.1 degrees, something like that. I hope it is clear. Next. So let us see the previous question now. So some more questions we'll discuss here for competitive exams, very very important. So I'll discuss some more questions here based on general properties only. General properties only. So let us see now questions now. So question number 4, since we have done 3 examples, now question number 4. The most abundant fifth A group element in Earth's crust. Most abundant fifth A group element in Earth's crust is, we can say straight away, nitrogen, because nitrogen contains 78% by volume in atmosphere. So the most abundant element in the atmosphere is also nitrogen, but most abundant element in Earth's crust of 15th group element is not nitrogen. Just wait. It is phosphorus, because it forms in the form of minerals and plants. So phosphorus, answer is phosphorus. So next question, the most abundant fifth group element is in Earth's crust is phosphorus. Please see here now. So the most abundant 50 group element is phosphorus. Next question, question number 5. And the most abundant element in the atmosphere is nitrogen. Now question number 5. Question number 5, very very important. Please note it down. This previous NEET question. The correct order of reducing abilities. The correct order is the answer I'm writing here directly without any options. The correct order of reducing abilities of fifth A group hydrates is of 50. As I told you, 15th group elements can also be called as fifth A group hydrides. They are asking hydrides. Reducing character hydrides is. So correct order is, now I'll write direct answer. As we go down the group, the reducing nature increases. So ammonia is less reducing than phosphine, than hydrates, that is arsenic hydride, than antimony hydride, less than bismuth hydride. Bismuth hydride is more reducing because it is a metallic hydride. Since bismuth is metal, so this is the increasing order, correct order of reducing abilities of fifth group hydrates. Next question, very very important. 6th question. The boiling point, decreasing order of boiling points of hydrates. They are asking decreasing order of Boiling points of hydrides. Boiling points of hydrides. This BP is called boiling points. Please note it down. Boiling points of hydrides. That is, the order is antimony hydride, very, very important, is greater than ammonia, greater than arsenic hydride, greater than phosphine. Because phosphine is a gas, ammonia and ammonia is a liquid. Antimony hydride is solid. Antimony hydride, ammonium hydride, ammonia, arsenic hydride, and phosphine. This is the order. This order is very, very important. Please note it down in your classwork. So, like these questions, you will be getting very, very important. Next question. Only based on general properties I'm discussing the questions. So, please note it down. The chemical formula of next we have acidic anhydride of nitrogen is question number 7. Acidic anhydride of nitrogen is acidic anhydride of nitrogen is very, very important. It is hydrazine, that is N3H azide. It is called as azide. So N3 is there means it is called azide. So this is the answer. N3H is the acidic anhydride of nitrogen is N3H. Next, question number 8. A stronger reducing agent among the following. A stronger reducing agent. I will give options here. A stronger reducing agent among the following. A stronger reducing agent among the following. Option 1, they have given ammonia. Option 2, phosphine. Option 3, antimony hydride. And option 4, bismuth hydride. So answer is what? They are asking reducing agents. Since metals are strong reducing agents than non-metals and metalloids. So the answer is 4th option. Bismuth hydride is strongest reducing agent among the hydrides of 15 group elements. Next question. More volatile hydride is. More volatile hydride is. They are given 4 options. That is hydrides of 15 group. Phosphine. Second one, ammonia. Third one, ammonia is a gas. Bismuth hydride is a solid. And fourth one, what we have, arsenic hydride. So the more volatile means phosphine. Even though it is gas, these two are gases, but more volatile is phosphine. I hope it is clear. Next question. Question number 10. Like these questions you will be getting. Now, the atomicity of white phosphorus. No, this will not discuss now because we have done only up to nitrogen. Nitrogen differs from other elements. Nitrogen question is based on anomalous property. Nitrogen differs from other elements among the 50 group due to among the 50 group due to option 1, small atomic size. Option 2, high electronegativity. Next, option C, absence of d orbitals. These are additional questions which we are going to give you. That's why I'm writing here. Absence of d orbitals. And fourth one, all of these. So by seeing the question only easily you can say nitrogen is having small atomic size when compared to all the atoms in the group. It has high electronegativity and absence of d orbitals, and that's why answer is all of these. I hope it is clear. So very important. So we have done the general properties of 15 group elements. Next class, and also we have done the properties of nitrogen. Next class we'll discuss more compounds of nitrogen as well as phosphorus. I hope it is clear. So I'm stopping this class. So everything, please note down what we have done here. Very important.